Okay, it looks like we've got the stream starting up. You should be able to see me shortly. It's coming along. Hopefully it'll popping up soon and you'll be able to see everything that's going on. There we go. Okay, looks like we're live. Good to see everybody. This is week 12. Sorry, I realized I forgot to send out an email yesterday letting everyone know what the status was this week and all that kind of stuff. But I will get that. I will send out an email shortly after this. But for those tuning in now, it will give you some of the details of what's going on, right? Okay, so we're heading into the home stretch. The big news is that, of course, the final project is due at the end of this week, and by that I mean it's due on Sunday, October 23rd, before 11:59 p.m. Pacific time. Now, on the just to remind everyone, on the assignment deadline, it's going to say anytime. It's going to say before October 24th, but that just means anytime on October 23rd. I'm working on trying to get them to change the way that displays so it's a little more obvious, right? So that's when the final project is due. I've posted the rubric and the guidelines, so you should be able to look through and see exactly what's expected of you. There were some questions about the how detailed the info tab should be, and yes, to some extent, the info tab in this is going to be more detailed than it would be for a normal NetLogo models library. That's because I don't want you to have to turn in two documents, right, for the final project. I just want you to turn in the one document, which will be the NetLogo file. So all the documentation is going to be in there, whereas normally you might have a paper or an article that accompanied the NetLogo file, right? So as a result of that, the info tab will be a little bit more beefed up. But I think if you look through the rubric and you look through the original model guidelines as to how you're going to get graded, it should be pretty obvious how to go about working on that, right? So that's due this Sunday at midnight, right? And then you have 2 weeks after that to do the peer reviews, which will be due on November 6th at midnight. November 6th at midnight is also the end date for the whole course. Which means that by November 6th at midnight, you have to have everything turned in, the peer reviews and the final test. So that's the deadlines. Again, they'll say on the course guidelines, they'll say something like due at November 7th for the peer review, but really that's November 6th, anytime before 11:59 p.m., right? Let's see. So the other thing I want to talk about today a little bit is that the topics that we're covering. So right now, we are covering Unit 9, which is Advanced Agent-Based Modeling. And the first one was up, and the first one is not in the textbook at all, the first subunit. That was actually just some recent work I've been doing, and I thought I would kind of throw it out there as one of the places I see the future of agent-based modeling going. I think that you're going to see a lot of these attempts to combine agent-based modeling with big data in interesting ways, and I think that's a really cool idea. The next couple are from the textbook, the next couple of subunits, and then this basically is the one time when the unit number doesn't correspond to the chapter number. Unit 9 is roughly covering chapter 8 of the textbook, so if you have the textbook or are following along at home, you can check out chapter 8 for that. We're going to cover some topics like some advanced model conceptual design guidelines. So we talked a little bit about basic model guidelines. We're going to talk a little bit more about more detailed ways to think about how you might want to design your model. We're going to talk about the extensions in NetLogo, including the social network extension, the GIS extension. We're going to talk about the controlling API, the ability to link to Mathematica, things like that. And we're going to talk about participatory simulation, and we're going to talk about the integration of agent-based modeling with systems dynamic modeling, which is something some people I think are interested in. If there are any other topics, any other questions, I know there was some interest in thinking about behavior search. I'm happy to cover that in an office hour. I think we've already kind of spent some time on it in the class itself, so I don't want to go back to it in the class. But if there's a particular question that people have about behavior search, I'm happy to answer that. Just go ahead and send it in. So, so great, a great little kind of, so a bunch of people showing up. Edward, Krug, thanks for joining us. Martin, thanks for joining us. Gustavo, Eugene, Jerry, all there. Thanks again. Gustavo's asking about ray tracing is really what you're asking about, Gustavo, not point of view. Okay, I got it. So there is a ray tracing extension. I don't plan on covering it. That's a little too advanced for this course and a little bit outside the mainstream, I think. But yeah, I'm happy. There's definitely some work that's been done on that. Forrest has built some great models in that space. I'll see what I can do, but I think maybe if I actually don't know that extension very well, so it would take me getting up to speed a little bit on what's going on with that extension. I worked with Forrest on it a long time ago. HubNet, and Jerry is asking about HubNet and participatory simulation. Yes, HubNet is the participatory simulation framework I'm going to discuss. Participatory simulation is a more general term than HubNet, right? But HubNet is the framework in NetLogo that makes participatory simulation possible. And we'll talk about the more general context as well as the particular context within NetLogo. Cool. Okay. So that's it for the kind of details of what's going on, right? In terms of specific questions, I don't have a lot to cover this week, but if anyone in the chat wants to throw some questions out there, or if anyone wants to tweet or email, let me know. I did want to go over some of the stuff that's been going on in the forums and talk a little bit about that for sure. So that was my main goal for today, essentially. So just trying to scan the tweets real quick to see if there's anything that really happened there that was interesting. Not that much I could see. Okay. So let's see. Gustavo wants an overview of the behavior search results for Unit 7. What were the results? Just an overview. Sure. I guess what you're saying is you want to know more about all those different files that make up the behavior search results. Let me see if I can pull it up quickly. I'm logged in over there. Okay, hold on one second. We've got to pull up the right files, the right space. Nope, that's not what I want to do. I want to go to main applications. Okay. Sorry, just got to pull up this directory and then I'll switch over and show you guys what I'm doing. I think it's logo 5.2. Okay. Yeah, okay. Do I actually, maybe I have it. Hold on one second. Sorry about this. Maybe I have it in the actual folder, class folder directory. Okay. Let's see if I can find it there real quick. Let's see. Classes slides. Okay, Unit 7. Unit 6, actually, I believe it was. Okay. Having trouble finding it. I'll keep looking while I look at some other questions real quick. Jerry's asking, I just saw and download George Mason's Field Guide to NetLogo. Could you talk about George Mason's work in ABM's areas of focus? Well, I'd rather have somebody from George Mason discuss that. I mean, I know the guys there pretty well. I don't want to kind of characterize everything that they've done. But, they do a lot of different stuff. Rob Extel, I know he's been very interested recently in looking at modeling economic systems. He built a big a one-to-one agent-based model of the entire U.S. labor market that was kind of cool. But you'd have to, I don't know if I would call that an area of focus. That's definitely something he's been playing around with. The other, then there's Claudio Ciaffi-Ravelli. Claudio does a lot of work on political science modeling. He's done some work on modeling refugee camps and things like that. Then there's also the work being done by Andrew Crooks. Andrew does some really good work combining geographic data with agent-based modeling. But they also have a ton of PhD students working with them, doing applications all over the place, a lot of diffusion and innovation work, some work on creativity. Yes, they are going to have a conference in late November celebrating the 20th anniversary, I believe, of Growing Artificial Societies, the Josh Epstein and Rob Axtell book. I may be at it. I'm trying to work out the schedule. Rob asked me to come by and talk a little bit about the future of agent-based modeling, things along those lines. Trying to work that into my schedule, but we may not be able to work it out because of schedule conflicts I have on my end. It should be a good conference, though. If you're in the DC area, or even if you want to make a trip out there to go to it, I think it's going to be a nice little conference as for what's going on there, right? Okay. So I highly recommend checking out their work. Like I said, I don't know if I would talk about their focus. Oh, and the other thing I should mention there is that Sean Luke, who's so all three of those people, the first three people I mentioned, Rob Axtell, Claudio Ciaffi-Ravelli, and Rob Axtell is the name, Priv AC, about the one who's building the economic model. That's the Axtell in the Axtell and Epstein book on one of the first books on agent-based modeling. So Rob Axtell, Claudio Ciaffi-Ravelli, Andrew Crooks, they're all in the I can't remember the exact name because it changed. They actually merged recently with another department. But they're in the Center for Social Complexity, I believe it's called, which is also related to the academic department of computational social science. But then there's also a computer science department there that's really well known, in particularly at George Mason, particularly Sean Luke, who is the author of the Mason programming language, which is an agent-based modeling toolkit that exists that's really, really efficient. If you want something that runs really fast, I highly recommend you look at Sean Luke's work. And then there is Ken DeYoung is there as well. Ken is a fantastic scholar, does a lot of work in evolutionary computation, and has done some work in agent-based modeling as well. So Ken is another fantastic scholar at George Mason. So they have a lot of good work going on there. Will I be organizing any ABM conferences in the future? Yes, probably. However, I tend not to organize just around ABM, but rather more generally around complex systems. I just got to North Carolina State, as I mentioned earlier in this semester, and as a result of that, I don't quite have everything set up here, and so I'm kind of still in the process of doing that. But I am on the committee, as Jerry mentions. I'm on the committee of a conference in DC. That will be in early spring of 2017, late spring of 2017, April-ish, called CAPS. And I can put the link in the Google chat for those who are interested, and I can post it somewhere else as well. This is a little bit different than your general agent-based modeling conference. That's not the right link. Here's the right link. It's going to be on specifically about using complex systems for understanding public policy and understanding analytics for social good, right? So how can we use agent-based modeling, things like that, to understand, access to education, healthcare, social ecological systems, group decisions. It's kind of general. It's organized by the Journal for Policy and Complex Systems, and my old research center, the Center for Complexity in Business up at University of Maryland, will host it. So that's going to be the next conference, the major conference I'll be involved with quite a bit. Okay, so I think I found the behavior search files I want to load up, and load up the behavior search GUI, and I'm going to also load up the adoption match file that we looked at before. Let me just bring this up. Okay, and now I'll switch this over so you can see what I'm doing in just a second. Okay. See. So let me add in this window, and we'll get this going. Okay. Just gotta find behavior search in this list. Okay. Nope, not that one. It's the wrong one. There we go. Okay. So there's the behavior search window that you've seen before. And Gustavo asked a little bit about what was the other data files that are created. So when you run behavior search, right, you get it takes off and it runs, and you guys can't see the search progress because it pops up on your front window, and the streamer, I have to add each window I want to add in. So I'm just going to let it run through, and then I'm going to pull up a terminal that's in the same directory so that you can see it from there. Just wait for it to finish running. But essentially, behavior search does generate a bunch of files when it runs, and those files give you all sorts of details about the run of the model. And they're well documented if you go to behaviorsearch.org. They're fairly well explained up there. Forrest is good about documenting his code. But just to kind of quickly show you what's in there, let's see, this is unit 7, subunit 4, okay. And I'm having trouble getting into the files I want. There we go, okay. Unit 7, subunit 4, okay. Okay. Okay, now we got them all. Now let me pull this window up instead so you can see what I'm seeing. Let's pull this up. Where did oh, there it is. Okay. So I'll delete that one and add in the new one. Okay. Pulling up. Where is it? There we go. That's it? Yep. Okay. Okay, it's a little small. Let me tweak that for you. Okay, and I'll turn myself off. Okay. So, okay. So, what I'm actually in is not actually the directory the behavior search is running in, but rather the directory where I output the data files to, right? And this is the one where we're trying to find the parameters that best match an empirical data set, right? And so you notice we have these, so behavior search, so the .b search file, this one right here, that's the one we created actually that has all the parameters for behavior search in it, right? But these other ones are a bunch of data files that the behavior search automatically creates. So one is called besthistory.csv, right? So if I look at that real quick, what that includes is every time that behavior search finds a best match a new best, so a solution to the problem that has a better fitness than any solution found before, then it, at that point, records that in this file, right? So it found the first one in its 10th evaluation, right? And it tells you, it has a record of what all the parameters were. So number of agents, broadcast influence, et cetera, right? And so you can see over time how the parameters changed that it thought were the best parameters, right? In fact, at one point it even looked at the random network, but most of the time it was using a preferential attachment network, right, to match this data, which makes sense. So that's what best history has in it. So anytime it discovers one, it puts it in there. Now, there's another one that's very similar called final best, right? And final best basically just has the best solution found per search for that particular search run, right? Now, the reason why it's called final bests with an S at the end and not best with a T is because you can have more than one. You can have more than one if you are doing more than one search, right? So you could tell behavior search, I want to do 10 searches. And what that does is because the algorithm, I mean, think about it, there's a lot of stochasticity in behavior search, right? Because you have the stochasticity of the model itself, but the algorithms that we're using to find optimal values in the model are often stochastic themselves, right? Genetic algorithms, at one point it was described as the best solution to finding answers to problems that's not guaranteed to get you a good solution, right? And what is meant by that is that it finds good solutions, but because it's a stochastic search, there's no guarantees that it's going to find the best possible space, right? And so you can do multiple searches to kind of reset the stochasticity of each of the individual searches. So final best records the best for each of the individual searches. Now there's also one called final checked best, right? And in our particular case, because of the way we set up this model, it actually, what it does is, so because you know that the solutions are stochastic, right, and you know the model is stochastic, you might run a model, say, 10 times and get an answer, and you think that that is now the best answer you've seen so far, right? But is it really, right? Or did that particular solution just get very, very lucky on those 10 runs? So you can tell behavior search that for each of the best solutions it ever finds, to run it again, say X number of times, to really make sure that that's the best solution, right? And basically decrease the variance you have around the expected value of the solution, right? And so there's a parameter called best checking replicates, and best checking replicates will allow you to specify that, right? So final checked best actually gives you the best solutions after you've done these checks, right? And what the rechecked value of that fitness is, right? Okay, let's see. Actually, you can't type into the streaming window. I have to type into the actual window. Okay. So then we have the model run history, the data file. So more model run history. This actually gives you every single evaluation that the model does. So every time it runs a model and it gets a result, it records the results of that model. So this is the most detailed of all the files, right? It gives you every single run that possibly happens, right? Okay. And then there is also objective function history, which is smaller. If I remember correctly, it basically just gives you the objective function outputs, right? So yeah, so this gives you, so in the model run history, we had every single time the model had ever been run, right? Here we're looking at, for each individual solution, what was the average of its model runs, right? So it's labeled evaluation 10, but it's actually giving you the best fitness and the checked best value as well, right? So if you see, those are actually a little bit different here. You can see that really obviously, right? The one is a little bit smaller than the other because it's checking the fitness that it's found so far, right? So we have those two, and then the final one is just the search config.xml file. That's just a file that behavior search generates itself to specify the search configuration, how the system is set up, right? And so it tells us where the model is. It's essentially similar to a .n logo file in some respects, but for this particular, for behavior search instead, right? And it's very similar to the adoption match.b search file in many ways, right? In fact, not sure how it's different. I'll have to ask Forrest what the difference is. So those are those files. Hopefully that helps you understand a little bit about how behavior search works and what it does, and gives you some insight into what's going on there. I'm going to shut down behavior search just because it's a Java program, so it takes up a lot of memory and causes the stream to start buffering a little bit. Yeah, I've got everything else shut down. Okay. So Joseph Lucero writes in, can you recommend a master's doctorate course in Europe for complexity studies or complexity economics? Let me switch back on my camera. Okay. It's a good question. I actually am not super familiar with all the courses that are out there in that space. There are, I know more about where the researchers are who are doing good works in this space. There's a lot of interesting work going on in Germany for sure, in this area. I actually just gave a keynote on agent-based modeling at the University of Münster. They've been organizing a meeting there on a fairly regular basis. It's a good university, and there's definitely some people interested in complex systems there. There's also a group at Hamburg Harbor, which isn't too far away from there as well, who are doing some interesting work in that space. And there's some good work going on in Italy and in England. I don't know much about the overall courses that are offered. I know more about the individual researchers who are working. If you have a particular location that you're looking at or something like that, shoot me an email. I am happy to try and think about names of people who might be in that space who would be interesting to talk to. And they might be able to tell you courses that are going on. Gustavo asked, what other ways would you expand on the chapter in the book on the history for ABMs? I think the biggest component, the reason we deliberately left this out, is because there's a lot of other stories about this. In fact, the Grimm and Railsback book goes into a lot more detail, is on individual-based modeling and ecology, right? I think that's a big spot where there's a lot of work that has been done that we don't talk about in the history, and we do that on purpose because we felt like it had been covered quite a bit already, right? That's the biggest missing component. If I was going to expand at other places, where would I expand? I mean, I think that primarily because it was Uri and I writing, and we're talking about the development of the primarily the agent-based modeling languages in the U.S., right? We did, following up on Joseph's question, we did overlook, some of the European work that was done in agent-based modeling. The European work has been more applied in general and less theory-driven, though, I hate to generalize that much. There is some spaces there. The Pietro Terriano's group in Italy and places and Rosaria Conta's work and Flaminio Squazzoni and Nigel Gilbert, right? We didn't talk much about what they had come from and where they had Klaus Treusch and the work on computational social modeling, right, for instance. There's been some fantastic work over there, that's for sure, and the history chapter doesn't talk too much about that. but that again also is fairly more modern history, right? As well, like I said, we tried to most of the history vignettes that we discussed cut off about the 1995-ish, right? And so that was kind of where we were searching for, because telling history that's less than 20 years old is a little bit difficult to do. Not sure what you're asking about, Gustavo, in terms of computation and languages. We definitely cover a bunch of languages in the history vignette, right, when we discuss things like object-oriented programming and C++ and Lisp and Cocoa, and some of the work on epsilon programming as well, or sorry, lambda functions as well. So yeah. Do I know anything about John Miller's new book, A Crude Look at the Whole, The Science of Complex Systems and Business Life Society? I have it on my Kindle, ready to read. That's basically the most I know. I love, the beginning part, I did start to read it, and it reads really well. John's great, he's fantastic. I think he does really cool work. A lot of the behavior search work, in fact, owes a huge debt to John. I think I mentioned that during the behavior search space. His work on active nonlinear testing was very much the inspiration for a lot of the work that we did on behavior search. And of course, in many ways, I believe he invented the words agent-based modeling as we currently use them, right? His work with John Holland on artificially adaptive economic agents, I believe it's the first time you see that word used in the sense we now mean it. And of course, John's work with Scott Page over the years in running the graduate workshop at economics, or in social sciences, I guess it's now called, at the Santa Fe Institute has been fantastic. And if you really want a great overview of the main concepts of agent-based modeling and computational social science and how they relate to complex systems, I highly recommend, I want to get the name right, I'm pretty sure I know it, but there is a book by John Miller and Scott Page called Complex Adaptive Systems, An Introduction to Computational Models of Social Life. I think that's one of the most readable introductions that covers a wide variety of topics on the role of complex adaptive systems and how it can be used to understand social systems in interesting ways. Though they also look at biology, physics, and computer science, and it's a great book. So let's see. But I look forward. I should say I very much look forward to reading John Miller's newest book. I gotta get some time to get around to that. I actually just kind of had a chance finally to read Holland's A Very Short Introduction to Complexity, which I should have had time for a long time ago because it is very short. It's only 80 pages long, but it's also a great book in that space. So just looking through the forums to see if there are any things that came up there. Just a reminder for those of us who joined late, right? We are extending the project deadline. Final project is now due on October 23rd before midnight Pacific time, 11:59 p.m. Final peer reviews are due November 6th, which means also the whole course is extended to November 6th in terms of doing any of the tests. But about 4 or 5 days ago, Dan Whalen did ask about adding a video on debugging, and I do think that would be great. I plan to add that into the next iteration of this course. I think that he talks about how you can use show and print to help watch a model during a run, and I do that all the time. And I should have discussed that. That makes perfect sense to me. But basically. Having some idea having the ability to debug your model is something we didn't talk about in this course. But yeah, there's some. I highly recommend taking a look at both the show and print commands to output intermediate values. Also, I use inspect a lot, right? To inspect a particular turtle, look at its results, and make sure it's running correctly. And one thing we didn't talk about, but I think I demoed a couple of times, is that you can inspect a turtle and then actually tell that turtle to run a particular piece of code. I think that's one of the really valuable things about the NetLogo modeling environment, is because of the fact that you have the ability to inspect any particular element, you can debug that element by itself. In many other modeling frameworks, being able to grab a single entity during runtime and inspect it is nearly impossible, right? And so I think that's a big benefit for the NetLogo modeling environment. So I will add a video on show and print in the future. It's a great way to kind of show intermediate ideas and monitor what's going on. I often also will just add, speaking of monitor, I'll just add monitors to my model that I don't plan on leaving in for the end result, just to look at what's going on over time, right? I think that's a great and fantastic use of those tools. And just making sure, add a video on debugging, putting it down officially in my notes for next year. There's been some questions about replication standards, and I had a little bit back and forth with one of the students. In a positive way, right? We had a constructive discussion, right? In the original Axtell et al. Paper, which actually has a number of great authors on it, there is a statement that stochastic models cannot achieve numerical identity in replication. In other words, if I run a stochastic model and then someone else builds a version of that stochastic model, that person cannot create exactly the same results as what I created. That is true to some extent, and it's highly unlikely, especially given the fact that there's so many different implementations. But as computer architectures have moved towards more sandbox architectures, where the programming languages are isolated from the overall hardware of the system, and Java was a great start for this in many ways, that has become less true. So that statement was written in the late 90s. I think that's a 99 paper or something like that. And at that point, right, software was very much tied to hardware, but now we've kind of split that layer more and more. What that means is it's still hard to get two pieces of software to replicate exactly the same numbers, but if you manage to get the exact same random number generator and you get the same seeds as the original model, theoretically it could be done even if I wrote the code completely separately for you. Now, there's a lot of reasons why it's very difficult to do, and in fact, there's a great editorial in Science this week or last week that I linked to on my Twitter feed about how difficult it is to do to reproduce other people's science, right? And in this case, it's from a computational person who is saying, even in their context, where they document very well and they record everything and they use version controls like Git and things like that, they still have problems reproducing models within their own lab. I definitely think that's the case, right? Because there's a lot of times we just don't document everything exactly correctly because we don't think it's necessary. But anyways, what I want to make the point is that under modern computer architectures, or modern software architectures, I should say, it should be possible to get numerical identity, but a lot of times you actually want to look at not exact matches in that data, but what we would call distribution equivalence or relational alignment, which we talk about in the section on replication, right? Distributional equivalence is that if I put a set of inputs into my model and you put a set of inputs into your model, the results are statistically indistinguishable for each other, right? And relational alignment is the idea that if I increase a parameter in my model and you increase the parameter in your model, the same set of outputs go down or up, right? And that's the idea that you have relational alignment. Those are achievable replication standards in a stochastic model, no matter what the hardware software implementation issue is. Sorry, that was a little digression, but still interesting. So Jerry asked what you think of NetLogo as an intro to CS. I think it's a great idea. In fact, I mean, I actually think, and Uri and I are both fond believers of the idea of the restructuration that agent-based modeling allows. I feel like it helps you understand a lot of new concepts. I mean, Logo was originally written as an intro to CS, right? That's why Seymour developed the Logo language, was to teach children how to think computationally and algorithmically, right? And to that extent, I think NetLogo is a great introduction. Now, is it a great introduction to modern computational languages, right? Like, say, some of the, like writing an app or developing in Java or, in some of the more embedded software languages or things like that. That I'm not as convinced about, right? But I think the most important part about learning computer science has nothing to do with a language so much as it has to do with learning how to think computationally, right? And to that extent, I think NetLogo is a great introduction. I also think that with the advent of the multi-level NetLogo that's coming out in the newest version of NetLogo, it will be much more amenable to moving directly on from there to other modern languages. Miguel, hi Miguel, nice to see you on board. Nice to see you here. And Gustavo posted the actual citation I was trying to get to about the reproducibility and how difficult it is. It's in the October 7th, 2016 Science. It's called The Hard Road to Reproducibility by Lorena A. Barba. If you want to take a look at that, as I said, it's also linked to on my Twitter stream, so you can follow me there, twitter.com/BillRand, and you can find it there as well. Okay. Something's going on with the video resolution where it's having problems all of a sudden. Hopefully this will switch. Okay. Well, it doesn't seem to be having any problems yet. Okay. Let me see, anything else going on, the other things in the forum. Gabby, the Complexity Explorer admin, she posted a nice update on the peer review system. I was going to go over that briefly, right? So the way it works is you are required to review 3 submissions. And so for the final project, the review stage will count as 1/3 of your grade. Right, so 2/3 of your grade is the grade you get back for the review. 1/3 is the fact that you complete your submissions, right? So you get the option to keep reviewing submissions every time you go back until the deadline, which I highly encourage, right? So you don't have to stop at 3. You can do as many as you want. When you start reviewing a submission and you refresh the page, you will still have the same submission review unless in between those times, that submission got 3 reviews, right? To make sure you're evaluating the correct submission, right, there will be a number that's visible on the web page and on the submission a zip file name. You should check to make sure those numbers match before you complete the review. This is because it all deals with the fact that we had some problems in the initial peer review example where people would start reviewing a file and then they would stop and they would refresh the page, and when they did that it gave them a new file to review, right? And the problem with that is that they weren't checking that it was the same file. They would fill out the review and then their review get attached to a different student, right? So let's imagine I'm reviewing Miguel's assignment, right? And I start to write my review, and now I refresh. Chances are I might now be reviewing actually Joseph's assignment, right? And so I put my comments in for Miguel's assignment on Joseph's review, and my comments to Miguel make no sense to Joseph. So we fixed this by basically making sure that there's a prominent number that identifies the review, right? And that number is also attached to the files that you get to review. Make sure those match before you finish your reviews, okay? And then finally, if you receive fewer than 3 reviews, it's not going to count against you in any way. And if you want additional reviews, you can request those, but we won't be automatically giving them out, right? Yeah, so anyway, we think we've now worked out all the bugs on the peer review system. Thank you for participating kind of in our previous one, where we kind of explored what those bugs might be, and I think we've worked them all out. Some great questions about the extensions. I'm not going to have time, unfortunately, to go through all the extensions, and I don't know all the extensions, right? So you can do some stuff by, like for instance, integrating with open sound control. Gustavo mentioned the ray tracer, right, which is great. So you can extend through a number of different ways. To really explore, to add on stuff to net logo, right? In many ways. A couple questions in the forum I haven't gotten to yet, but I wanted to take a look at soon. So there was a question about. So one question that came up last week that I want to talk about briefly was the history of my history was maybe a little simplistic when it came to discussing John von Neumann's work, and I totally admit that. I kind of I didn't. This is not supposed to be a history of computer science. It's a history of agent-based modeling, and so I brushed over a few of the details. Right. For instance, as many of you might know. There's now a big debate over what was the actual computer and what you define to be a computer, right? And there's at least 3 contenders that people talk about. The ENIAC being one of them, the Conrad Zeus's Z1, right? And the Atanasoff Berry machine as well, right? I have revised the slides. Actually, in the posted versions of the slides, you'll see it now says one of the first computers, right? I'm not going to weigh in as to which of those is the strongest case, though. There are some interesting books. Actually, Art Burks's wife, Alice Burks, wrote a very interesting book on the history of the computer. I highly recommend you check it out. And then there was also some discussion about whether or not von Neumann and Stanislaw Ulam really invented the cellular automata. As far as I know, they were the first ones to formalize the notion. There were some other discussions around lattice-based computation at that time, but no one had really formalized the notions of cellular automata. So just a couple of little clarifications as to what's going on. Some people point to Zeus, but Zeus's work on Conrad Zeus's work on cellular automata was published much later, and then there's a paper, very interesting paper about modeling biology using cellular automata that's published. It's back at around the same time computers are being invented by Wiener and Rosenblatt, right? But as I said, I believe that von Neumann and Ulam were the first to really formalize the notion of cellular automata. So that much I'll stick to. Right? Now, there are 2 questions in Unit 9 that I want to talk about. Agent-based modeling versus agent-based engineering systems, right? And this is from James Farkas. Been a lot of work with cooperating robots, drones, etc., cooperating, communicating to solve a problem, modeling external problem. And this sort of thing going on in the NetLogo world. How about feedback and robust control of physical and or social physical systems? Yes, there has been. In fact, I did some work during one of my postdocs actually trying to build models of drone coordination behavior. I think that there's a big, as I mentioned at least once in the office hours, there's a big difference between agent-based modeling. There isn't a big difference, but there is a difference of viewpoint between agent-based modeling and multi-agent systems engineering. Agent-based modeling is usually used to describe social systems, whereas multi-agent systems engineering is used to write rules that optimize a particular system, right? Try to achieve a particular goal. And a lot of the drones and robotic control work in that space. That being said, there is some really cool work being done at the intersection of agent-based modeling and physical systems. There is some great extensions to the NetLogo modeling and Violet library under GoGoLab and under Arduino that allow you to actually use NetLogo to control robotic elements. And the person who I think of the most when I think about that work is a guy named Paulo Blickstein, who was a graduate student when I was a postdoc at Northwestern, who's now a professor at Stanford University, runs a kind of a whole lab dedicated to how to use maker spaces to help students learn, right? And so if you're interested in that topic, I highly recommend you look at some of Paulo's work in this space. James also asked if causal state models are related to Markov models. And this is a great question. I should have mentioned this during the talk. So those of you who haven't looked at Unit 9.1, this might not make sense yet, but causal state models are a method of taking time series data and inferring a state model directly from that data. In fact, inferring rules for agent behavior from that data is one way to think of it, right? The big difference between causal state models and Markov models is that, first of all, most Markov models, you specify structures a priori, and then you learn the probabilities of transitions, right? In a causal state model, you're learning the structure as well as learning the probabilities of transitions. The other thing is, and this is the bigger difference, causal state models are not Markovian in the way we originally think of it, right? The state space that we're looking at is history dependent, right? So we're saying that things that happened 10 time steps ago can affect our current state, right? That's the whole goal of causal state modeling. That being said, the eventual model that is generated from the causal state model algorithm, the scissor algorithm, is Markovian, because now we've remapped the underlying external world state space into a world in which history is not necessary to know. If I know where people are in that history. So in other words, essentially causal state modeling allows you to translate from a non-Markovian world to a Markovian world, right? This is one way to think of it. But it is non-Markovian in the original sense, since the underlying state space is a non-Markovian state space. That might be too in the weeds for some people, but I don't. The important thing to learn is that causal state modeling gives us a powerful way to learn agent-based rules directly from big data. Finally, I have a question on the live chat from Joseph Lucera about, can you recommend a graduate level mathematics textbook for complexity studies, complex adaptive systems? Great question. I don't know, most of my work is more on the computational side rather than the mathematics side, so this is not a space that I do a lot of work in. That being said, probably the best overview book I know right now. Now John Miller's new book I'm sure would be great. I'm not sure, as I haven't gotten far into it, and I'm not sure how in depth it is mathematically. Knowing John, I don't think it'll probably be, it'll definitely have math in it, but I don't know if it'll go into a whole lot of detail. Melanie Mitchell has a book called Complexity: A Guided Tour, but again, that's fairly high level and not really mathematically graduate focused. So I wouldn't recommend, if that's the interesting case, I don't know if I would look at that one in particular. It's a tough question. I'm trying to think of what is a good one. There was one a while ago that was fairly popular, which was Yanir Bar-Yam's work on dynamics of complex systems. That one might be get more in depth into some of the mathematical systems rather than some of the other ones. But that one at this point, I believe, that was published in '97, so it's getting a little dated at this point. Probably, I don't know. I mean, it just won't have the most recent things in it. And Nino Baccaro's book, Modeling Complex Systems, which takes a physics-based approach, that might be a good one to think about for sure. That's a 2010 book, so it's not really that old at this point. Other than that, there's a bunch of great books in space. If you want one from Gustavo's got a great recommendation, which is, the courses here at SFI, the other courses on Complexity Explorer. Those would be a great way to cover some of that material. Another thing I wanted to mention is I haven't had a chance to mention this yet, and it's not really a complex systems book, but it covers a lot of the same ground, is the book Computational Beauty of Nature, which is a fantastic textbook by Gary Flake, really well done, covers a lot of the same topics that you would cover in a complex system space. It's also getting old, a little bit old at this point, 1998, right? But I really love that book. It's a great book. So hopefully that gives you some ideas as to interesting spaces to look at. If you missed any of those, Joseph, feel free to shoot me an email at abm@complexityexplorer.org, and I'll send you links to the appropriate ones. I think that's it for today. Unless there are any other questions, I think I'll probably wrap up the stream. But just a quick reminder in the announcements at the top. We have, the final project is due Sunday at 11:59 p.m. Pacific time. The peer reviews are due 2 weeks after. So that is on November 6th, 11:59 Pacific time. And just a quick note, right? Make sure when you're doing peer reviews, you do at least 3, and make sure that the number that is on the peer review assignment matches up with the number that you're looking at, right? So that they all match up appropriately. And that will keep you from submitting comments for the wrong model. The other thing to know, of course, is that November, I keep losing the date, November 6th is also the last day of the course, so you make sure you do all your tests by then as well. The rest of the Unit 9 should be up in the next day or two. And other than that, I think that's it for today. Take care, and I'll see you all next week. We have 2 more weeks to go.